Good evening, everyone. My name is Amit Sharma, and I am working in information security for more than a decade, doing what I like. Unfortunately, my story is not like sitting in a garage and playing around with computers, and then you just get inside the brains of hackers, and then you invoke your interest of doing hacking. I am an electronics and communication engineer. I always wanted to be. I wanted to design chips in nanotechnology, but unfortunately, I will say fortunately, I landed onto computers. And that is where I started learning more about it. So the interest in information security started when I was in third year of my college. And one of the projects that I took up was cryptography. And I loved mathematics. And that's how the journey started. And then I was lucky enough to be a part of the 2008 recession. But I got a job in application security. And from then onwards, it has been my love of life. I have served very different roles across my career. Have done a lot of different things like risk management, cloud native security, Kubernetes. But somehow I was not able to go away from application security. And the ever-changing world is actually making it more challenging. And that's how I have kept my interest in this area as well. So today we are going to discuss about one of the most famous topics of application security, the dark side of it, because it is dynamic application security testing, which is in the black box area, right? A little bit of history before we go to the major changes that happened with the advent of DevSecOps. Initially, when we started testing software, it was mostly looking into different kind of source code, different kind of languages, looking into architectures and whatnot. And then the world changed a little bit, and people started doing testing on running applications. At that particular point of time, there was nothing called as DAST, but people were actually going through the application, going through different kind of URLs, and they were identifying vulnerabilities. And one fine day, one gentleman, I don't know who, decided that, okay, let's automate it. We want to make a tool which is going to exactly do what we are doing manually. And that's how the big area of application security got created, which was dynamic application security testing. So today we are going to look into what exactly it is, a little bit into the technology itself, what is required as a part of DAST or doing DAST. And then we'll see how it has changed with the advent of DevSecOps, and whether we should adopt traditional testing techniques in the new world or not. And feel free to ask any questions in between. It's more of like a conversation and exchanging of thoughts rather than just showing the presentation slides. So wish me luck. So the first aspect is what is exactly DAST? So if you go from testing perspective, there are different kind of testing. One is called as white box, one is called as gray box, and in between it's black box. So when you're looking into the source code of the application that you're developing, it's basically called as white box testing, because you're actually transparently looking into the code that you're actually writing. Now, when you compile the code, you no more have control on the code that you're writing. Now, it's a different entity altogether, right? Like in Apocalypse, you just give some kind of medicine and somebody else comes out of the room. And that's where black box technology comes into picture, wherein you don't know what exactly is in the black box, who built it, what kind of source code it is. You don't have any information. So basically, there is something going inside that black box, and there is something coming out of it. What happens inside stays inside. Nobody knows what exactly happens. Now, when we want to test these kind of entities, the only way to do it is try to check the behavior of the black box. It's very simple. Like, okay, if you want to have a conversation with somebody, the first thing you're going to do is say hello. And if he doesn't understand what is hello, he's just going to keep quiet and look at you very seriously. And then you're going to say, hey, maybe I'll try something else. And then you will actually go inside and see what other languages do I know. Maybe Chinese, or maybe Russian, or maybe German. And you start communicating with them by just saying hello in the language, and suddenly like, hey, hi. He responds back. And you're like, okay, now I know exactly what is going on within that particular black box. And that's exactly how the testing started as well. So basically, there are two different entities. Now, we need to talk to each other. And in application language, it's something called as protocol, which is basically the language in which both the different machines understand each other. So it's actually requesting something. And if it replies back, it says, okay, now I understand, and we can communicate further. Now, let's see if there is a change in behavior. So you're talking to the same person, and now you decide to say, hey, let's play around with him and say some abusive words to him. Let's see how he behaves. And then you start with, hey, dog, hey, cat, or hey, XYZ. And you see the change in behavior of the person at certain point of time, the more you start to tease him. And that's exactly the testing is all about. So you start putting some kind of payload in that particular request and monitor the behavior of the response that you get out of the black box. Now, on that basis, you basically define on how we can actually take advantage of this black box from an attacker's perspective. And that's how all of these games started. So first, we were doing this manually, and then we thought, okay, if we have a list of all those abusive words, and if we automate it, I can go outside, have a cup of coffee while the guy who has been built by me will do the job. And then started the new era of dynamic application security scanners. Now, when we talk about this, then there are certain advantages and disadvantages of this as well. So let's look at what are the advantages of testing these kind of applications via the DAST technology. So some of the advantages are, and the biggest one is that there is no requirement of source code, which means you can pretty much test anything because you have to just send a request and you have to just look at the response. On that basis, we can pretty much test anything. So I need not know what Java looks like. I need not know what .NET, C, C++, whatever. If it is developing a web application, I will be able to test it. So it is pretty much language agnostic, which gave me the higher power as well. So now the only thing I need to learn is the language in which I can interact with that particular application, which is the HTTP protocol here. Then the second advantage is that you can actually test everything at runtime. So you need not start testing much more earlier, and you can actually see, hey, once you develop the application, come to me and then I'll take care of it. And you can actually sit back and relax and look at the development team saying that, hey, once you're done, let me know, and then I'll start my job, which with the changes in software industry also became an impediment of these kind of technologies as well. So let's look at some of the disadvantages. The first one is, yes, a runtime environment is required. So I have to actually wait to test something until and unless it's ready to run. So we cannot test just the engine until and unless the whole car is available and I can drive around. And then the second aspect was there is no source code context to the outcome. Why? Because it's a black box technology, which was actually creating a lot of problems when we were looking into remediating those issues. So let's say we know the behavior, but now we want to make sure that we actually resolve it. With that, you have to first understand, and okay, what part of the black box actually responded to this particular target or to this particular payload, and then you have to start troubleshooting from there and then start resolving it, which was basically a biggest problem of the developers. Like, okay, hey, I don't know where the code is that I need to fix, which actually also created one of the challenges, which means you need to have some kind of context of security as well. You need to know what exactly is going on. What is this change in behavior called as, or how does it work? How can we understand what is going on so that we can respond to the solution of it? Which means a new language for the developers to learn, which is again a challenge for them. Okay, should I learn a new language or not? And the third one was things it cannot see, it cannot scan or cannot test, which means whatever messages you're sending, the response you're getting, you can only test those, which might conclude that, hey, have you covered everything? Do you know all the aspects of the behavior of the entity that you are testing? Which was actually a very big question mark on how do we conclude whether we have actually covered the whole part of the testing mechanism of it. So with these different disadvantages and advantages, it was still a very, very nice technology to have. because you were able to understand the issues at runtime. So let's also see what are the different steps that you should take to go ahead and scan a particular application. One of them is, first, you're going to spider through the application, which means whenever you are actually trying to scan, you should see what you want to scan, which means you have to just crawl through the application and see what are the different paths which are available, what are the different parameters which are available, if there is any kind of cookies, tokens, parameters. As a part of your application, whatever are the parameters which are required for you to communicate to the outside world are actually explored in this area. So the output is pretty much proportional to how good your spider or crawling mechanism is. Now the second one is, once you have identified it, then you need to pinpoint on, okay, these are the injection points that I'm going to put my payloads in, which is how intelligent your system is. It might be that you keep on having a conversation with the person, or you exactly know that one statement that is going to bring down the person as well. So it is the intelligence of the system that actually made the output more and more strong, because less amount of time was required to identify a particular issue. And the third one was exactly running those attacks and identifying the issues as well. So does it look simple to you guys? It is. Come on, it's not a trick question. But wait, brace yourself. There are some challenges which are available. Now, the output is basically dependent on a lot of different things. Now, one of the things is that how are the different aspects of these scanning mechanisms taking place? Because one of the aspects is, how are you configuring that particular application? So the better you configure the application, the DAST scanner, the better the results are. Now, if you're not configuring it properly, the output is not what you expect. So when you look at the web application, you go to a URL, you load the application, then you give some kind of authentication details, and then you see the rest of the application. But now if you're configuring your scanner in such a way that you're not providing any kind of authentication details, the scanner will not know that there is something which exists. Why? Because it's a black box scanner. It exactly knows what you actually feed in. The more information you give to him, the more output it produces. And the better information you give it to him, the more quality results you get out of it. So then the researchers were like, okay, let us try to see how we can feed this authentication information to the scanner in an automated fashion so that it doesn't complain to me. And it's also looking into the different pages that are authenticated in nature. And on that basis, the spidering and discovery and all those stages comes into picture. Now, once it has identified the issue, the next challenge comes into picture, which is it something that we should be really looking at? Is it exploitable in nature? Which means if there is an issue which is identified, you need certain kind of expertise to conclude whether we can take advantage from that issue or not. And it's not easy to get. You need certain kind of information from the application, so you should have context of it. Then you need certain kind of expertise so that you can actually conclude whether these things are possible in real time or not. Yeah, okay. While all of these things are going on, the world suddenly decided to change. The security guys were very much interested in identifying all of these issues, and they were actually getting a lot of issues at runtime because it was very, very easy to do. You just point to the website and just sit back and relax, and then let the guy do the job. So they were really, really happy. And then things changed. The software industry changed. There were a lot of new things which came into picture. Some of them I think you guys can pretty much relate to. So one of them is, hey, we need more automation. We need some cultural changes. We need some more tools. How many of you have heard the infamous word like let's shift left? We do not want any kind of hindrance when we want to actually deploy something. So we want to keep the velocity of deployment intact. So all of these came into picture. And there was a tsunami which was going on in the security organizations like, now how can we actually do something about it? Because there are so many different technologies that we have which are also important as traditional testing. But how are we going to adapt to the ever-changing world? So today I'm going to give you certain aspects on if you want to integrate dynamic technologies like black box testing techniques as a part of your DevOps? What are the impediments that you might face? And how you can actually decide whether this should be a part of your testing methodologies as a part of your DevSecOps strategy or not. So let's start. So I will start with when you're actually integrating any kind of technology as a part of CI/CD, what are the things that you should actually keep in mind? Everybody knows about CI/CD and all those things, yeah? Okay. First part is when you're looking at the spidering and crawling part. So as we are dealing with the technology which is black box in nature, it will produce output which you feed input to. So one of the inputs that you can actually provide to is the spidering of the engine and the crawling of the engine. That is how it knows about what are the different URLs that are present. The next one is time for consuming the QA test. So one of the aspects that you can actually consider while integrating DAST as a part of your CI/CD pipeline is take advantage of your QA systems. If you're already doing any kind of tests which are functional in nature, then you can basically integrate that as a part of your CI/CD pipeline and put it across to the DAST engine, saying that, hey, we are already doing our functional tests, which means it is validating the functionality of the application. Can you just pick up the information from there and then scan only that part? Which means you should have the information about how you can scope your application testing at that particular point of time. The next one is whenever you're doing it, when your hands are getting really dirty by integrating these technologies in CI/CD pipelines, there are something called as webhooks. That is one of the ways in which you integrate the solution. This is how you pull the information from the QA tests back to the DAST engine via some webhooks. So these webhooks are very prone to fail as well. So there has to be someone who actually has the understanding of this and can actually come to your rescue whenever these are failing. The third one is how do you validate the coverage? So you should also know that, okay, as we are delivering all things so fastly, we should know what kind of coverage a particular test cycle is providing to you. The next one is the most challenging one, and the authentication workflow, which means whenever you're actually feeding this information to those webhooks, you should also consider whether the authentication pages are getting loaded on those webhooks or not, which means you should actually give the intelligence to the engine about how the session IDs are being handled, how the cookies are being handled, and if you're actually developing something like multi-factor authentication based application, then it's a different ball game altogether. Then comes the scanning part. So this is basically how you feed information to the spider, who is basically going to send all this information to the engine so that it can produce results. Now, when this information is collected by the spider, it goes to the scanning engine, but this particular guy has some more challenges as well. One of them is it is going to add some more time as a part of your CI/CD pipelines. There are some strategies in which you can actually run these scans in parallel, which means you're only going to get information which is not useful to you. So people have actually started using it as a parallel pipeline, and then they integrated in the main pipeline. But ultimately, the output that it was producing was not useful to them because it was just showing issues which were QA issues. If you get an issue like SSL not implemented, or the flag of the cookie is not set, and the developer guy is going to see, yeah, we're going to do this in production anyhow. And the zeal of taking advantage of these technologies goes very, very down immediately. Like, okay, we are investing so much of time in terms of integrating these beautiful technologies as a part of our pipeline, and the issues that it is producing is cookie flag not set? Seriously? I'm not interested in this technology anymore. So we have to also see on how we can actually produce results which are valuable to the time they're investing as a part of integrating these beautiful technologies as a part of CI/CD pipelines. The next one is the can of worms, including but not limited to. I was actually thinking on what statement should I put to make sure all of these are covered. So when you're actually doing authenticated scans, there are a couple of things that are listed here, but this is just the starting. For example, how are you handling sessions? How are you handling cookies? So let's say if you are actually doing an authentication mechanism in such a way that once you log in, the cookie is getting updated. So while spidering, you actually got a cookie, and while scanning, you forgot to update the cookie, and then the scan fails. And then you're just thinking on what went wrong, which means extra input or effort from the DevOps guys in terms of resolving that. And then it is producing the issues like cookie flag not set. Not worth it. So these are some of the challenges when we look into how we want to integrate technologies like DAST as a part of the pipeline. So of course, there are different kind of technologies that are very nice. So when you're developing, you integrate DAST, which actually is a white box testing technique in which you identify issues as a part of your source code. And then you also do some kind of software composition analysis for third-party libraries, and then you build the artifact. If you're doing it in Docker, then some more scanning techniques. And then finally, the artifact is ready where you can actually do some kind of dynamic testing. But there are new technologies as well, like IAST, which is interactive application security testing, which is taking a lot of pace in the industry because it's eradicating the challenges that were present as a part of DAST as well. That's how new technologies are born, right? So there was SAST, then came DAST, and then came IAST. So IAST actually provides you information which has a lot of source code context, which makes the life very easy of the developer. And then you are actually away from all the challenges about authentication mechanisms, cookies, webhooks, and all those kind of things. Though it brings a different challenge on the table, but it's much more easier to resolve in today's technological landscape than these challenges. So that was the aspect that I wanted to show you guys on how we can actually integrate as a part of the testing cycles and what are the challenges. Now that is one part of it. The second part is when there are issues that are basically created out of it. What are the different kind of steps that a developer does when you're basically scanning it, right? So let's say there is a Jira board and you have different functionality that is available, and then you're testing something, and then you're running the DAST solution, making the changes, rerunning the DAST solution, and committing it into the repo. So things that are increasing is time for initial scanning that is getting added to your pipeline. Then time to understand and fix the issue. It's a very big challenge. Not everybody understands about the security aspect of a particular vulnerability, and then there is some kind of education that is required around it as well. And then time to scan after fixing the issue as well. So all of these are pretty much getting added to the velocity of the deployment that you have. Now there is a guy underneath, which is basically the security engineer, and his job is pretty much to interact with different people and first make them understand what a vulnerability is and then fight with them to resolve it, because here nobody is going to resolve it on their own until and unless you decide to break the bill. And the other aspect is he is the guy who is being approached when there is a problem with the webhook or when there is a problem with the session cookie. And then you say that, hey, you have found a cross-site scripting and you need to actually resolve it. And the guys are, we don't want it because there is a WAF that is going to be present in the production. So we are not worried about it at all. So these are the real life challenges that usually you see when you're actually interacting with DevOps teams within the organization as well. Now, with this, there is some of the thoughts that I put when you want to integrate a DAST in CI/CD. I'm not saying that it is not possible. I have done it myself and for a lot of different customers of mine as well. So it is certainly possible. But the question is whether you want to do it or not. The amount of effort that you basically put in putting for one application and the amount of output that you receive for that particular application is 180 degrees to each other. And then just decide the effort on the basis of the number of applications that you actually want to do. So if you are the only security guy in your organization, in which most of the places you are, I believe, it's going to be a really challenging job for you to go to different teams, understand their application context, and then define those webhooks and authentication mechanisms and put it as part of your CI/CD pipeline. And then you get a call like, hey, the number of hours that we invested in this is like 2 FTEs for X amount of hours, and the only issues it is giving is SSL. I don't want it. And then you are like, yeah, he's right, but what can we do? So some of the things that you can do is first define what is the scope of the testing that you want to do. So one of the ways is, of course, if you're a mature organization and you're having a lot of functional tests in the picture, then try to augment that and help them define the scope for every pipeline. The second thing is, do not run it as a part of every pipeline. Tell them when there is a major change or major change in the code, that is the time you have to actually pick it up rather than doing it for every pipeline. Now, defining of the scope is one of the biggest impediments that we have seen as well, because not all of the teams know that what kind of changes should they pick up for the scanning to be really important for them. So sitting with the team, having some discussions around it, looking at some of the history of the commits that they have done into their application actually helps you define the scope in a very nice way. One of the ways that the new DAST technology companies are doing is just taking the HAR files. So HAR is basically HTTP archive files, and just feeding it to the scanner so that actually it is doing the job according to the HAR file itself. But it's basically static. And then you need to do some kind of changes for session cookies and tokens and all those kind of as well. Then define test cases as per technology. This is really important because some of the test cases might be not useful for the technology stack that you're developing on, and but it will take the time that it is actually defined for. So understanding the technology and refining the test cases as per the technology is also going to reduce the velocity of deployment, which is actually going to be really useful when you're running it very rigorously as a part of your pipeline. And don't scan often, define a testing strategy. And the last one is don't be afraid to fail, because integrating DAST as a part of the pipeline is not as easy as it looks like. So some of the organizations are advocating it as a part of running it as a part of your production, so that you're actually getting real issues, real challenges, not only from the application perspective, but also from the infrastructure perspective. But if you want to still run it as a part of your development lifecycle, then you have to be really conscious about what you're actually developing. With that, thank you all. And if you have any questions, let me know. Yes.
Question. I don't think, but let me ask a question.
Yeah.
So the big problem with this kind of testing, that if you find something, you still have to find it in the source code.
Yeah.
So I don't know if compilers are able to give some reference on where the memory or where the source codes line may.
Yep.
Yeah.
Yes, I think it's a very good question. And this was the same question by the researchers like 7-8 years before as well, that how can they provide more context to the engine? So DAST was a complete black box technology. And one of the challenge that it had was, it is able to identify an SQL injection. And then you take the SQL injection and go to the desk of developers. Here is your SQL injection. Can you fix it for me? And the guy is like, okay, the first thing I need to do is where it is. And then you come back 1 week after and like, okay, did you resolve it? And then it's like, okay, I did not find it where the source code is. And that's how new technologies came into picture. And the next session that Martin is taking is about exactly that technology, which is interactive application security testing, which gives you some information on this. Yeah.
I will answer the question.
All right. I don't want to steal the show.
It's a great question.
Yes.
So, can you talk about the challenges of running DAST in single-page applications?
Yep.
And also in the applications that are, we talked about request response, HAR files, etc. Modern applications do not work anymore in the isolated request and response. It's
Yep.
always connected, clicking on multiple buttons, etc. How the DAST solutions will be able to, solve these challenges?
Yep. That's actually...
Sorry. Because we have the audio recording here, but not for the audience, and we repeat the question.
Okay. Oh, the question was, how are DAST engines able to understand the single-page applications and do scanning in that area? Right. Okay. Actually, it's a very nice question, and that is also one of the challenges with DAST as well. So single-page applications was also the part of when I showed the world changed. It is not very easy to identify issues, but nowadays there are some DAST engines which have developed parsing engines for JavaScript. So what they do is they just scan and parse the whole JavaScript and then try to understand it. But not every engine is as strong as others. But for single page applications, I think DAST is not a very appropriate solution. It may find certain stuff, but it will definitely require certain manual intervention as well. And to supersede it, I think Martin is also going to cover about how different technologies will help in identifying issues in single page applications as well. I hate you. It's not recorded.
Hi. You mentioned that there's scalability challenges with the DAST.
Yes.
Please talk more about that.
Yes. So the question is scalability. How can you scale DAST solutions in organization? Yes. So if you noticed, there are two different ways to scale. One is depending upon what kind of strategies do you have within your organization. One is, okay, there is a centralized security team which is actually handling all these requests about DAST. So once you develop it, you go to the guy and say that, hey, my application is ready. Can you scan it for me? And then the scalability depends upon how much application scanning the guy can handle or the engine that you have in the organization can handle. The second approach is if you have integrated it as a part of your CI/CD pipeline. Then the challenge comes is if everything is working fine and have you defined it properly or not. So the amount of hours that actually goes in setting it up is the question or the parameter that you should be looking at. So let's say if you have a security champions program, you're already a very mature organization, then you can take advantage of the security guys on how you can actually scope the application as well as build those webhooks. And then it depends upon how you want to replicate that across the organization. So the challenges are basically the amount of time that it actually takes in terms of integrating it. If it is integrated well, and if you're not changing a lot in your application, then everything works fine. But if you're changing very often, that means you also have to update those webhooks, those challenges like session IDs, session IDs and cookies, which you need to change, or some parameters or any kind of events that are changing as a part of your application as well, which might.
Dames en heren, het gebouw aan de Heidelberglaan 15 gaat over 15 minuten sluiten. We willen u vriendelijk verzoeken het gebouw te verlaten. Denkt u aan uw waardevolle spullen en wilt u ramen en deuren sluiten? We wensen u een goede terugreis en tot ziens. Good evening, ladies and gentlemen. The building of the Heidelberglaan 15 is closing in 15 minutes. We kindly request you to leave as soon as possible. Please make sure you don't forget any valuable items and shut windows and doors upon leaving. Have a nice trip home and we will see you soon.
Thank you.
That's rules.
Yes. So that is exactly what the challenges are. So usually people do not have time to complete the functionality, and in between there are new things that you have to maintain as a part of your application lifecycle management, for example. So you have to consider one more aspect as a part of your CI/CD pipeline that you need to update regularly if your applications are getting changed very often. If it is not and you have made it once, no problem.
Great answer. Thank you.
Yeah, go ahead.
One more.
Yeah. Martin is going to answer that. Sorry.
Maybe. So, what if you combine SEA and SAST results to test DAST? So, just to see if you're really vulnerable for a specific SAST or SEA vulnerability. For example, if you have an SEA vulnerability, not in the beginning, but further up into the codes, you might be interested if you're really vulnerable for that.
If I understood your
question is there a movement? Is this something DAST is working on?
if I understood your question correctly, it is repeating of the question that whether the output of SAST and SCA can be utilized to enhance the DAST testing, correct?
Yeah.
Okay. Yeah. The biggest challenge in this one is that you will not be able to relate on what was exactly in the compiled code and what was exactly that was identified in the static code. So DAST is pretty much on the dynamic and runtime area. So the only way to augment is if you actually put something in the compiler. So for example, the JVM, and then you say that, okay, if the code is running in the JVM, then I know exactly what code is responsible for what HTTP frameworks or what HTTP request, because now you're actually looking into the framework, which is calling the code into the memory to serve the request. But out of the results, it is very difficult task. It is possible, but it's not the right way to go, I'll say. A lot of inputs will go in. But that is exactly what Martin is going to talk about.
One last question. I will close the session probably. Yes.
Who defines the test case? Because security engineer defines the test cases. It stops being a black box, but it's a gray box because you need to understand a little bit of the application. So, when is this test case defined on this process, on the CI/CD pipeline? Is this done on the trend modeling phase, and then incorporated your templates? How do you do this process?
Yeah, that's an excellent question. So the question is, who exactly defines the test cases and when are those test cases defined? Correct? So the best answer of this one, not the best, the most feasible answer to this one can be that it depends upon the collaboration that you have with your security leg of the organization. It can start directly from the design phase. It can also start at the stage when you're doing threat modeling. There are multiple answers to this. Like if you're actually defining user stories, abuser stories, that can be one of those. But the second one is, let's say you don't want to define security use cases as a part of the scanning mechanism. You just want to scan during the functional use cases itself. So then there is no role of a security use case. So you just define, I want to test if there is a vulnerability available in the login functionality or workflow of the application. So the functional test case guy or the QA guy is going to say, hey, go to the URL, put the username and password in the text box of username and password, click on login, that's about it. And the job of the DAST engine or the IAST engine that Martin is going to talk about will actually help you identify if there is a vulnerability in that area. Now, the next aspect to this will be defining security use cases. Like, okay, what happens if there is a script tag in the username or password field? So it totally depends upon at what stage you want to actually adopt it. The more early you do, the more maturity is reflected as an outcome. Does that make sense? Okay. And over to Martin. Thank you, guys.